Okay, so let's take a look at our lesson for today. Today we're going to look at parametrics in a little bit of a different way. We're going to learn how to go back and forth for different forms, like from rectangular form to parametric form and back and forth. You recall we did this a few weeks ago with polar. Remember how we had some polar equations? We were taking them from polar form to rectangular form and back and forth, that kind of thing. That's what we're going to be working on today, but with parametrics. Okay, so that's the premise of what we're going to be doing. We're going to turn parametrics into rectangular or rectangular to parametrics. Okay, so let's start with our, what does it mean? We're going to start with changing parametrics to rectangular. Basically what that means is to get rid of, so let's just kind of highlight this right here. When it says eliminate the parameter, what they're asking us to do is to get rid of the t. T is our parameter. Time is our parameter. And they're asking us to get rid of time. In other words, they're asking us to turn it into a rectangular equation with just x's and y's. Get rid of t, only have x and or y. Okay, so that's this first kind. So what I would like to do is write some steps. Y'all know how I love to write steps out. So this is easiest way to do this is substitution. So I'm going to write that out. Easiest way is substitution. And so the first step, what we would do is we're going to choose one equation and solve for t. Now, it doesn't really matter which equation we choose, but we should make it beneficial to ourselves. Like in this first example, I really wouldn't want to use the x equation to solve for t because I've got a t squared and a t. That seems like that would be really hard. So I don't want to do that. So instead, I'm going to take the y equation and I'm going to solve it for t. The second step, what I would do is I would substitute. So I'm going to substitute that equation into the other one. Okay, so I'm going to substitute that equation into the other one. So these are our steps for eliminating the parameter for non-trig. This is for non-trig functions. This is for just things with t's and x's and y's. No trig. Okay? That's what we do. This is the easiest way, and we're going to do those steps. Okay, so let's do that. Let's see, I'm going to take the y one and solve that for t. So t is going to be, I'll move the 1 over, y plus 1. Now what I'm going to do is I'm going to take this y plus 1 and I'm going to substitute it into the other equation for the t's. I'm basically eliminating, I'm getting rid of the t's. Okay, so let's do that. So x is going to equal, and then we open that up and put a y plus 1 in it. And then open that other t up and put a y plus 1 in it. Okay, so we have just eliminated the parameter. We've done steps 1 and 2. The last thing that we have to do is to simplify. Just get everything simplified and fixed up. So let's do that. Of course, we're going to have to FOIL the y plus 1 times y plus 1 is y squared plus 2y plus 1. Then I'm going to distribute the negative 3. So negative 3y minus 3. So let's clean that up. Let's see, so I've got a y squared, 2y minus 3y is a minus y, 1 minus 3 is a negative 2. They want us to describe the shape of the curve. So I hope that looks kind of familiar to you, not perfectly familiar, because we have, usually see it with x's. So I'm just going to remind you, this is just a reminder, if we had, if it looked like this, y equals x squared minus x minus 2, what kind of equation would that be? What kind of graph would that make? It's squared. Think back from last parabola. It's a parabola. This is a parabola. So this kind, what we're used to, is a parabola that opens either up or down. This kind is one that we're going to learn more about after the break. This is a parabola that, and you would just need to say parabola. You don't need to say which way it opens. This is a parabola which opens left or right. Okay, and so this would be our answer. And actually this parabola opens right, but again, you don't have to know that. We really haven't gone in depth into that kind of equation. You might be able to surmise that from what we have, like if it was y equals, what would that do? That would open up. So we would open to the positive, which would be right. So that is, we eliminated the parameter, we don't have any t's anymore, and we described the shape of the curve. How are we doing? And that's if you have like x's and t's and y's, and it tells you to eliminate the parameter, which means, get rid of the t's. Yes, ma'am.
Do we have to know do we have to know left or right, up or down?
You don't.
So we can just say parabola?
Just parabola. Not now. We will after the break. We will get more in detail. We're not really getting in too much detail yet. We just need to know that that is a parabola.
Okay.
All right. Any other questions for that first one? Okay. So this next one is eliminating the parameter as well, but it has trig. So this has got different rules. Different rules. First off, let's remind, we have this fun thing. Y'all remember this? Sine squared plus cosine squared is 1. Yes, it's not going away. It's never going away. So what we do with this kind is we utilize that concept, and I'm going to show you how we do that. Okay, so if it's trig, I'm going to write instructions up here. If it's trig, okay, we've actually got a branch right here. I'm going to call this right here is A, right? That's our amplitude from old days, right? Amplitude from, like old days. If trig, okay, so if A is the same in both equations, then you're going to go this route. Number 1, you're going to square both sides. Okay. I'm going to actually do this one much slower. I'm going to go one step at a time, and I'm going to show you 2 examples at the same time. One if A is the same, and one if A is different in both equations. Okay. And I'll write that example out to the side. Let's say if we had x equals 3 cosine t and y equals 4 sine t. Okay, this is an extra example that demonstrates the other option. These are the only 2 options there are, ladies. So if A is the same in both equations, like our example on our problem here, we immediately square both sides. If A is different in both equations, we have an extra step. We isolate, that's a great math word, right? Isolate. Isolate means get by itself. We isolate trig, and then step 2, then we square both sides. There's just one extra step. If A is not the same. Okay, so let's do step 1 for each problem. So I'm going to square both sides, and I get x squared equals 4 cosine squared, and I get y squared equals 4 sine squared. Okay, that's step 1. Okay, so let's do the same thing on our other problem where they're different. Let me give myself some more room. Okay, so first I want to get the cosine by itself, so I'm going to divide both sides by 3. So I have x over 3 equals cosine, and I have y over 4 equals sine. Then I'm going to square both sides. So I have x squared over 9 equals cosine squared, and I have y squared over 16 equals sine squared. Now I want to pause there for a minute and make sure we're all caught up. Okay, so we're delineating if A is the same or different. That's significant for us. Is A the same or different? Okay. Our next step is actually the same. Step 2 and this and step 3, we're going to add the equations together. And we know we can add and subtract equations before. We do that when we do solving systems with elimination, right? We've done that before. We've subtracted equations. We know that's a thing. The only thing you need to make sure is that the equals are lined up. So I'm going to write them like an addition problem. So I'm going to write one on top of the other one like an addition problem. Do my little line. So I add down. So I've got x squared plus y squared equals 4 cosine squared plus 4 sine squared. Okay, I'm going to do the same thing over here. I've got x squared over 9 equals cosine squared, and you don't have to rewrite it so that they're linked like this. I'm just doing it to make sure we have a clear picture of what's going on. I'm going to add. And so then I get x squared over 9 plus y squared over 16 equals cosine squared plus sine squared. Okay, I'll pause here for a second. So we squared both sides after whichever scenario we had, then we added. Are we all okay? Okay. On this side, we're going to factor A out of the right side. Okay, so I've got x squared plus y squared equals 4 times cosine squared plus sine squared. And we're literally almost at the exact same place in both of these scenarios. So what do we know about cosine squared plus sine squared? It's 1, right? It's 1. So the last thing that we do, step 4, is we use Pythag. So these are our steps. If it's trig, depending on if A is the same or different. Okay, so we get x squared plus y squared is 4. And we get x squared over 9 plus y squared over 16 is 1. Now let's talk about the shape of the curve. I am hoping, perhaps from geometry or from some of our previous work, we will remember what this creates. What does that create? Do we remember? That is a circle. X squared plus y squared equals a number is a circle. We would have seen that with in polar when we were working with polar. So this is a circle. The radius is 2, and we don't need to know that. Again, we're going to get much more into details of these objects after the break. But that's a circle of radius 2. This one over here is actually an ellipse. And we won't get into any details about the ellipse. I'm just going to call it an ellipse. So this one is an ellipse. And that's an ellipse, so let me add something to it. It's centered at 0. They're both centered at 0, 0. They're centered at the origin. It's more complex when they're not centered at the origin, and we're not going to do that before the break. Okay? A little bit more complicated. This is an ellipse centered at the origin. Okay, and again, you wouldn't need to know that if I asked you that on a test to describe the shape. You just need to know if it's x squared plus y squared is a number, that's a circle. If it's x squared over something plus y squared over something equals 1, that's an ellipse. All right, how are we doing? Are we okay? Okay. Now let's go to our other scenario, and that is where we're going from rectangular to parametric. Okay, from rectangular. Does anyone still need any of these notes? Is everybody okay? Okay. So this first kind is the kind where they tell you. So this is a different than the number 4. Here is where they tell us, they're telling us how to insert the T. They're telling us that. We don't have to figure it out. They're just telling us how to do it. Okay? So, we have, this is a parabola. We have a parabola that's in rectangular form, and we're going to write it in parametric form according to how they have told us to do it. So this first one, they tell us t is x. Well, that's easy. So that's my first equation, t equals x. Great. Okay, I need a y equation. So I'm going to substitute t for x in here. That's going to give me y equals t squared minus 4. And I'm done. That's my parametric equations. They told me exactly how to convert it. They told me that t was x, and so we went with that. The next one is a little bit more complex because t isn't just x, it's actually 4x plus 1. A little bit harder, but not too bad. So let's first figure out the x equation. That would be handy. So let's solve for x. So t minus 1 is 4x. So x is going to be 1/4 times t minus 1. And if you want to distribute the 1/4, please, by all means, do so. I'm just kind of leaving it non-distributed. So that's my first equation. So to get my y equal equation, what do you think I'm going to have to do? I'm going to have to take that 1/4 t minus 1, and so I've got to take this, and I've got to sub it in here for x. And that's what we're doing. Okay, so let's do that. Let's do this out to the side. So I've got y equals, so I'll open up a hole. I'm going to insert 1/4 t minus 1 squared minus 4. So there are a lot of different ways that you could deal with that first very strange looking thing. I actually squared the 1/4 and then I squared the t minus 1 separately. You don't have to. You can go ahead and distribute the 1/4 and then square. I just wanted to minimize the amount of time I had to deal with the fraction. So 1/4 squared is 1/16. And then t minus 1 times t minus 1 is t squared minus 2t plus 1. So I FOILed that out. Okay. The last thing that I need to do is just clean it up. It just needs to be cleaned up because that's kind of a mess. So I'm going to have to distribute the 1/16. 1/16 t squared minus, let's see, 2/16 is what, 1/8 t plus 1/16. I need 4 to be in 16th. Let's see, what is 16 times 4? 6 times 4 is 24. What is 64? So I'm going to write 4 as 64/16, just so I have a common denominator already. Just makes my life easier. Okay, so the second equation for this is y equals 1/16 t squared minus 1/8 t, and what is that, minus 63/16. And I've written parametric equations for that. Okay, so they'll just tell us what to do. If they don't tell you what to do, I would highly recommend that you do part A. You would just say t equals x and do it that way. I would highly recommend that if they don't tell you what to do. They're normally going to tell you what to do. Okay, how are we doing there? So we have converted a parabola to parametric equations. Okay, very last thing that we're going to do is we're going to convert an ellipse to parametric equations. Okay, we need some background before we get into this problem. So I'm going to write down standard forms. Let's write it up here. So we want standard form of an ellipse / circle centered at 0, 0 is this set of parametric equations: x equals a for amplitude, cosine b, our normal, when we were working graphing trig, it's the normal b, that's related to the period, and y equals a sine b of t. How do you think we can tell a circle and ellipse apart if it's written in parametric form? We just did that in a bit of a different form. Yes, ma'am.
Isn't like one the says like the fraction in the circle's just like x and y squared?
It is. It so is. And why does it turn out that way? When we're in parametric form, what is different? Oh, let's look up here. If A is the same in both equations, it gave us a circle. It gave us a circle. Okay. I thought I could write with a highlighter. That was a big fail. Okay, so it's a circle. And if A is different in both equations, what did it give us? An ellipse. Gave us an ellipse. I just want you to understand where everything comes from. That's where it comes from. Okay? So here, and this is a standard form. This is parametric form. This is a standard form in parametrics of an ellipse or a circle. And we just talked about how to tell the ellipse and a circle apart. How is that again? How do we tell if we're in parametric form whether we have an ellipse or a circle? If A is the same or if A is different, that's how we tell. If A is the same or A is different. I also need to give you, since we haven't really talked about this before, this is a good precursor to what we're doing after the break. This is standard form for ellipse centered at 0, 0. And I can write for circle too. And we'll write a circle right here. Okay, so for an ellipse, it's x squared over a squared plus y squared over b squared is 1. For a circle, it's x squared plus y squared equals r squared. Ooh, we should recognize that. Where have we seen x squared plus y squared equals r squared before? Polar, in polar. That's actually the standard equation of a circle at 0, 0, who's centered at 0, 0. I hate to break it to you, we're not always going to be centered at 0, 0, but when we are, that's what we have. Okay. So, let's look at what our task is. So this over here is rectangular form. So we have standard form of ellipse, a circle, centered at 0, 0 in parametric form and in rectangular form. Okay, so now they are asking us to find parametric equations for the ellipse where the parameter is t. Of course, that's what we're going to be using in time and seconds. Okay, so we've talked about this before. You may not recall the whole clockwise business. Does anyone recall the whole clockwise business from last time? How did we determine? Clockwise is the wrong way, by the way. All right, it's the wrong way. It goes clockwise. And what caused it to be clockwise? Does anybody remember? Exactly. If x is with sine and y is with cosine, if they're mismatched, this means that we need to mismatch we need to put x with sine and we need to put y with cosine. We need to mismatch them so that they'll rotate clockwise. And the clockwise takes care of starting at this point. We don't need to worry about that. Those are related for us. Those are related. We don't need to worry about starting at the point 0.03 because going clockwise, mismatching these is going to cause it to happen. All right, so let's start building our equations. So I have an x equals and a y equals. X equals something, that's the a. We know we need to mismatch, so this is sine of something t. I don't know what a and b are yet. We're going to have to figure that out. I'll show you how to do that. And y is going to be matched. There's something in front of the cosine, and there's something there. So we need to find a and b. Okay, the a and b that are right up here. This is what we're talking about. We're looking for these a's and b's. All right. So a, let's start with a. A is related to a squared and b squared in the standard formula. A is related to a squared and b squared in the standard formula. That's A. We're going to do A first. This is it's in our standard formula. I'm going to put that over 1. I know it is over 1. We just normally don't write it because, I don't know, we just normally don't write it. So for our purposes, so A is going to come from here. It's going to be related to this and this, to this and this. That's what A is going to be related to a squared and b squared. So basically a in this scenario is either going to be a or b. So look at the number under the x. That's a 1. So the square root of 1 goes with 1. It goes with the x. It doesn't go with the sign. It goes with the x. Look at the number under the y. That's a 9. The square root of 9 is 3. It goes with the y. That's how I get those numbers. The numbers in front of sine and cosine come from the denominators of the standard form. And they're paired. They are paired with the variable that they are underneath. They're paired like that. The 1 goes with the x, the 3 goes with the y. It doesn't matter whether it's sine or cosine. Makes no difference. Okay, that's where the a comes from. How are we doing with the a? Okay, so let's talk about where the b comes from. B, we know, is related to the period. This says 1 revolution equals 1 second. Our period with parametrics, let me put this in a different color. Our period in parametrics is related to time, not angles. Our period is related to time, not angles. So we still use period equals 2 pi over b, but this period is going to be time. The period is going to be time. Okay, so we have the time was 1 second. So I have 1 equals 2 pi over b. So I cross multiply, I solve, and I get b is 2 pi. So that's what goes here. B is 2 pi. Okay, the very last thing that we need to do is we need to put a restriction so this poor little ellipse doesn't just go round and round and round forever. The movement doesn't go round and round forever. How long does it take to go around one time? 1 second. So my restriction is going to be 0 less than equal to t less than equal to 1. It's 1 second. Okay, how are we doing? Okay, on the next one, part B, we're taking the same equation, the same ellipse, and we're going to, this time, we're going to go counterclockwise. Okay, and counterclockwise means what? We need to match x with what? A cosine, x with cosine, and we need to match y with sine. Okay, that deals with that. And our period is going to require, so we've got 2 seconds for a complete revolution. So we'll get to that in just a moment. Let's start building our parametric. All right, so x we're going to put with cosine, and y we're going to put with sine. That deals with our rotation. A is still related to the numbers a squared and b squared. It's still related. 1 went with the x, and 3 went with the y. That's not going to change. That goes with the x and the y. It has nothing to do with the sine or cosine. Okay, are we fine with finding the a? It's the same as in part A. Okay, the only difference, so we had 2 differences. One, it's counterclockwise, so we had to match them, you know, the proper way, shall I say. And the other is we have a different period. This time it takes, for 1 revolution, it takes 2 seconds. It takes 2 seconds. Okay, so period equals 2 pi over b. So 2 equals 2 pi over b. I'm going to cross multiply. 2b equals 2 pi. So b is pi. That should ring some bells from previous. So I'm just going to slide pi in there. Okay. Now, last thing to add is a restriction. How long does it take to go all the way around once? 2 seconds. So it's 0 less than equal to t less than equal to 2. And we've got it.